or omniscience. It depends on, I like the double entendre. So, yeah, so the context for this, and okay, so when I was doing a business impact assessment at Kite Pharma last year, one of the things that was, definitely clear is that, the impact of an issue and outage was often the patient's death. And I mean, they were manufacturing therapies that were therapies of a last resort where, the client had already been through a number of treatments, and this was sort of a therapy that was could make or break them. They were having very good results in terms of their therapies, but that was very much their context. And so a couple of slides I have at the beginning are, you know, who are we talking about? And I mean, we're talking about patient level therapies. We're not talking about mass production. We're not talking about big assembly lines. We're talking about sort of things manufactured in like labs. So yeah, and in terms of the overall supply chain, and this was another aspect that I looked up at, because supply chain traceability all the way from, they called this a vein to vein manufacturing process from, extracting the blood from a patient that was terminally ill, shipping it to the manufacturer, infusing what's called a CAR gene, and then which produces CAR T, and then they incubate it, they wait for it to grow, wait for it ready to harvest, and then expand it, and then package it to ship it off, back to the patient. So the products that these companies are manufacturing are just amazing and just so critical, to the patients, their families, etc. So yeah, so just so much that can go wrong. And so the what sort of interested me in this was sort of the aspect of, well, how can we introduce redundancy and use LLMs or VLMs in this case to reliably sort of improve the end result. So this is the manufacturing sort of facility. And so during different phases, I mean, it's literally in a room where you may have a biosafety cabinet, you have an incubator, and then you have the bench where other sort of devices sit. So it's very small. One of the drivers that they're trying to do in terms of manufacturing as well is drive things to being able to do inline monitoring. So instead of doing tests where they have to sort of extract a sample, have a camera or other sort of devices where you can sort of inspect what's going on without having to disrupt manufacturing. So, very, a lot of complexities, a lot of potential points for failure, but with a high sort of impact to failure, like at the individual level. So, and that's sort of the hardcore intro. Before I was going to ask if there's any questions, but I included that in case there were, to give people a little bit of context of why it was important and sort of some of the complexity and process flows. So this gets a little bit more into sort of the vision specific, and on the left-hand side, if you see, so these are some of the operation steps and also some of the things that they need to look for to see, like in terms of a product, is it ready for release, etc. So, some of the simple things to imagine is, doing something like cell counts and doing a cell count for specific cells expressing certain characteristics, but also looking for things like cell death, etc. So, okay. So when I was doing a deeper dive, one of the very cool products I ran into was called Landing AI. And okay, I see my timer. And Landing AI. It's from the team of Andrew Ng, is you've probably heard that name. And the very cool thing that they did with their product is that they have a core process that does, in essence, like an architectural trade-off analysis. Like you give it the requirements, and based on those requirements, it sort of expands them to specific steps, looks for candidate products, and then based on those products, it will suggest and recommend it. And then the other key thing that they did is that they abstracted sort of the calls to the back end where these various LLMs can sit. And so in terms of object detection, which was the key sort of framework that I was looking for here, so like, detecting specific types of cells, etc. That was sort of where, there was three core vision models, OWL, Grounding, Dino, and Florence 2. And so what I ended up focusing in on was looking for opportunities to be able to fine tune Florence 2. So the other thing that I did in terms of the solution is that, which even when calling APIs, not just LLMs, is that we've got a product called Weave from Weights and Biases that does an awesome job at being able to instrument these calls and help me reverse engineer the product very quickly. Okay, so in terms of when I was doing discovery and looking at alternatives in terms of vision language models, OWL and Dino were two that I looked at earlier. OWL out of the box did pretty good with the right prompt. And sort of in terms of, sorry, it's so small, but in terms of complexity, detect brain tumor and brain tumor in terms of complexity, it was almost like it, the more words you threw at it, the more difficult time it had. But, tumor, I mean, in terms of it nailed it. It didn't sort of get confused by eye sockets. It knew where the tumor was. Dino, Grounding Dino, which is an object detection model that's been around for at least a year and has been strong, didn't detect it. And Florence 2 and Pelagemma, there was a couple of issues here. I dropped looking at Pelagemma because when I was querying, I couldn't get a good baseline. A lot of the sort of detection I tried to do in these types of models, it wouldn't give me a bad inference. It would just say, as a generic model, I can't answer that. And so since I didn't have a good starting point, I didn't do it. But Florence 2, it's not here because Florence 2, object detection, you don't pass it a prompt, you pass it a task. You tell it you're an object detection model in essence, and that's all that you pass it. So when I looked at doing the validation at the sort of the request level, when it was doing object detection to begin with, non-fine-tuned, there was two different scenarios I looked at. I fine-tuned both based on cells and cell types, and I also did it based on liver samples, so liver biopsies. So, and it's small, but blood samples, 9 times out of 10, it was detecting as jellyfish, and these liver samples, based on the staining, wanted to say it was a flower. So, yeah, so that was kind of the starting point. And I tuned sort of more rounds with, or more epochs with the blood samples, but there was less sort of, it's not, there was fewer sort of samples overall. And I think the quality wasn't quite as good. And the complexity based on the number of sort of items to detect was much higher compared to the liver biopsy. The liver biopsy was primarily that, it wasn't, 20 to 40 cells. It was, one sort of liver disease or condition detecting. So, but very positive and very quick results in terms of being able to fine tune. Okay, So the proving ground that I created was just to be able to visualize it. Um, it was, okay, how much time do I have left? Is it over? It's telling me 8:54 remaining. Why is that?
Yeah, Don, you are at time now if you want to just wrap up with a final sentence.
Okay, that's fine. I will, yeah. So sorry about that. Yeah, so in terms of issues, fine tuning was imperfect, focusing on the blood samples. So that is an opportunity to both, I think primarily it's look at potentially switch away from the blood samples until I can get better sort of source data. Improving the overall sort of evaluation and fine tuning data flow. Appreciated Chris's coaching and help there. Yeah, so the other thing is getting back to this solution from landing AI is get it to the point of, dynamically sort of divide the work by a specialized team of experts, like these vision language models based on, the specific sort of symptom that you're looking for.
Thank
So
you.
sorry for messing up time.
No, you're fine.